The last aspect of acid-base concepts that we are going to treat now is titration. So if you look at titration, is one of the laboratory techniques that we use to determine the unknown concentration. Is a what? A laboratory technique that we use to determine the unknown concentration with known concentration in the presence of what? Of indicators. That is what titration. And is a practical aspect of what? Of chemistry. Like all know that what the chemistry practical divided into two parts. We have qualitative and then we have quantitative. So we have what? Volumetric analysis and then we have what? Salt analysis. So under volumetric analysis, we have titration. Is deal with what? The analysis of what? Of volume. So let us look at what titration now by definition. Titration is a process of adding standard solution from burette. There is a standard solution called analyte, called titrant. Called what? Titrant. Standard solution called what? Titrant. From burette into conical flask. Conical flask which contain unknown solution called analyte or titrant till reaction completes in the presence of indicator. See, look at titration. Is a what? Laboratory techniques that is used to determine the unknown solution substance from known solution. In this definition now, we have like three terms there: standard solution, titrant, we have what we call what? Analyte, titrant, and in the what? Indicator. So titration is a process of adding what? adding known solution. We always put known solution into what? Burette, and unknown solution into the conical flask. The process of adding the known solution in the word burette into the conical flask to the unknown in the presence of what? Of indicators. So the reaction is complete is called titration. Don't bother yourself on this what? These underlined terms. I will explain them. Before I will explain the what? The terms, let us move to the what? The types of what? Titration. Types of titration. Types of titration. There are four basic types of titration. The first one we have acid base titration. The second one we have oxidation reduction. This oxidation reduction by what? Titration. We can also call them what? Redox by what? Titration. And the fourth one, the third one, we have, yes, the third one, we have complexometric by what? Titration. And the fourth one, we have precipitation by what? Titration. See, like I said earlier, the aim of titration is for what? For us to determine the unknown concentration. So we use titration to determine the what? The unknown what? Unknown concentration. Please note it. Concentration of what? Of a solution. So in acid-base titration is used to determine the unknown concentration of what? Of acid. Is used to what? To determine unknown concentration of what? Of acid or base. Is depend on what? Unknown. This oxidation and reduction titration is used to determine the unknown concentration of substance that is undergo redox reaction. It's used to determine the what? The concentration of what? Of substance that is undergo oxidation and reduction. Complexometric titration is also used to what? To determine the concentration of a complex with metal that is formed a coordinate what? Covalent bond. Is used to determine the what? The concentration of what? Of a complex with a metallic what? Ions. Where what? The precipitated titration is used to what? To determine the concentration of a precipitate substance in solution. That is what definition for the what? For the three of them. But in this class, our major interest in this touch is what? Is acid-base titration. But before I will explain acid-base titration, let me explain the basic terminology we have in what? In a acid-base what? In a titration. Basic what? Terms in titration. So if you are talking of basic term in titration, then let's start from the first one here. We have titrants. Titrant is a known concentration. So, solution of knowing concentration is a solution of knowing concentration. Let me write it. Titrant is a what? Is a solution of known what? Concentration. That is titrant. Any concentration that is what is solution is what is knowing. We call it what? Titrant. And we always put it in what? In the burette. And then you will determine the volume of titrant by measure the initial and final. And the second one is we have what we call analyte. The analyte, we can also call it what? Titrant. So this is a what? A solution with unknown concentration. In titration, the concentration of titrant is what is unknown. We don't know it. But the volume of titrant will be what? Will be measured by pipettes. But the titrant, the solution is unknown, but the volume, we get it at the end of the what of titration. Or titrant means what? Unknowing concentration. Analyte, unknowing concentration. So is the concentration of this analyte you want to know? You will now try to what? To titrate the titrant with analyte. The process of analyze the concentration of what? Of unknown to get the concentration is called what? Titration. So we use this titrant to titrate this titrant against analyte in the presence of indicator to know the analyte that we call what? Titration. So analyte is what? Unknown concentration. What is the next one? And we also have what? Titration. Titration is a process of adding analyte a titrant into the what? Into the analyte in the presence of the indicator till the reaction is what? Is complete. So what will be the next one now is what? Let me use indicator or standard solution. Yes, the next one is what? We can also have what? Standard what? Solution. So this standard solution is we can also call it what? Titrant. See it here, I said a standard solution called titrant. So it's also what? Is a what? A known solution. Uh, is a what? A solution of known concentration. That is titrant. So this titrant, we can also this standard solution, we can also call it what? Titrant. So we can call what? Solution or titrant. The next one we have what we call what? End point. Yes, we have end what? End point. So you know we have end point and equivalent point. Both of them are what? They are not the same at all. End point, this is a point at which is a point at what? Which reaction between titrant, ti what? Titrant and let me titrant and analyte is what? Complete. Often indicated by color change. So the point at which what? The reaction between what titrant and analyte is completely what? The reaction between titrant and analyte is what? Is complete. We call it what? End point. A point where what? The reaction between titrant and analyte is complete. We call it end point. How are we determine the end point? The color of indicator will be what? Will be changed. So the end point is a point at which what? The reaction between titration and the analyte and titrant is what? Complete. And we often indicate them by what? By color what? Color change. That is what? End point. The next one is what? Is equivalent what? Equivalent points. Equivalent what? Equivalent point. So is a point at which the amount of titrant added, the amount of titrant added equal to amount of analyte present in solution or in titration. So end point and equivalent point are not the same. The point at which what? The reaction between what? Titrant and analyte complete and the color of the color change, called what? End point. But the point at which what? The total amount of what? Of analyte that is dropped for pipette is equal to the what? The amount of what? Of the amount of titrant that is dropped from pipette is equal to the what? To the amount of what? Of analyte we have in what? In the solution. When the amount of what? Of analyte is equal to the amount of what? Of titrant, we have equivalent points. But the point where the what? The two of them is being what? Completely react and the color of the solution change, we call it what? End point. And the end point is the end of the what? Of titration. So don't be confused between the end point and the what? And the equivalent what? Equivalent point. The next one is burette. Burette is a laboratory instruments used to measure the amount of titrant transfer to analyte in conical flask. We use bread to measure the what? The amount of what? Of titrant transfer to the what? To the analyte, which is what? Unknown what? Concentration. Is what? Pipette. So the pipette is also an what? Is also a laboratory what? Instrument that is used to what? To measure and transfer. That is used to what? Is used to measure and transfer. This is what? To measure and what? What? Transfer analyte into conical flask. So, 1, 2, 3, 4, 5, 6, 7. Let me just add one more under what? The basic terms used in titration. The last term that we are going to treat now here is what? Is indicator. Indicator is a what? Is a substance or organic dye. Is a substance, a what? Substance added to analyte to indicate the end point by color change or change in what? In color. So that is what? A substance that's added to the analyte, which is what? Unknown concentration to indicate the color change, to indicate the what? The end point by color what? By color change. That is what? Indicator. So that's all about what? The basic terms on titration. So, like I said earlier, that our major interest in this class is what? Acid-base titration. So let us start from acid-base titration. So, like I said, acid-base titration is a reaction or titration that is used to determine, or let me, this is used to determine the concentration of the concentration of unknown solution. It's used to what? To determine the concentration of what? Of unknown solution of acid or what? Or base. That is acid-base what? Titration. So if acid is known in solution, base will be what? Unknown. If base is known in solution, acid will be what? Unknown. That's what we use what? Acid-base titration for. And the acid-base titration, we can have it in what? In four ways or types of acid-base what? Titration. Types of acid-base what? Titration. So this can exist in what? In four ways. Like I said earlier, first you will have what? One, strong acid, titration of strong what? Acid versus titration of what? Of strong base. Strong acid versus what? Strong base. But if you are titrating strong acid versus strong base, what is the kind of indicator used? Yes, what type of indicator was used? Here, there is no suitable what? Here, any suitable indicators, any what? In the what? Indicator we can use for the what? Acid what? Strong acid versus what? Strong base. Example of strong acid, we say titration of what? Of HCl or HNO3 or H2SO4 and sodium hydroxide or potassium hydroxide. Titration of any one of these two. You use what? Any indicator. Methyl phenolphthalein, methyl. So the example two, we have what? Titration of strong acid versus weak base. We can have the titration of this kind too. For this kind of titration, what is the what of indicators what use? We have what? Strong acid versus what? Weak base. We can use what? Methyl orange. Methyl what? Orange indicator here. But example of what? The strong acid, you can see have what? HCl, H2SO4 or HNO3. The weak base, we have ammonium hydroxide. We have what? Ammonium hydroxide, weak base. Ammonium, this is the common one. Hydroxide, if I give the second one, I'll put it there. So the third one is what? We can have titration of a weak acid. Acid versus what next again? Strong base. Titration of strong acid and strong base. Here we use what? Phenolphthalein as what? As indicator. An example of what? Of weak acid, we all know that what? We have H2CO3, we have CH3, ethylenic acid, COH. For the strong base, sodium hydroxide and potassium hydroxide. So for this kind of titration, we use phenolphthalein. And the last one is not the least. We have what? Weak titration of weak acid versus titration of what? Of weak base. For this kind of titration, there is no what? No suitable indicator. An example of weak base, we know that what we have ammonium hydroxide. Example of weak acid, we have CH3, COOH, and this. These are the what? The choice of indicator used in acid-base what? Like what? Titration. And the last aspect I'm going to treat here is titration curve. Acid-base titration what? Curve. But this titration curve is meant for what? Acid-base titration only, not for redox titration or complestometric or precipitation titration. So if you still remember that what our main topic is what? Acid-base concept. Is you are not in what in a chemistry lab or at the chemistry lab now. I will have performed the experiments on what how I'm going to what to perform all these titrate all these titration. And if you want me to what to do video lectures on acid-base titration calculation, how to calculate what we call what acid-base titration, we have what we call a molality, we have what we call normality, and we have what we call what molarity. So all these things we used to calculate them on acid-base what titration. And if you want me to do video on this, tell me on what on comment section, first one. And if you see what video on oxidation and reduction titration, complexometric titration, precipitated what titration, tell me on the comment section. So I will respond. Yeah. Now let us continue the what acid-base what titration curve. This titration curve is the graph that explain or describe all these type of what of titration we have. And we have 4 types of titration. Therefore, the titration curve also divided into what? Into 4 parts. Yes. In our syllabus here in Nigeria, in fact, they used to test for titration curve in Unified Tertiary Examination Board called UTME. So it's the only exam board in Nigeria that is what? To test for this what? This titration what? Curve. So let us look at it now. Yes, let me say for first one, for strong acid versus what? Strong base. If you look at what? Strong acid and strong base. We all know that what? The pH of strong acid is between pH of strong acid is between know that what pH of strong acid is between what 1 to what to 3, and the pH for this strong base is also 13, 14, 7, 8, 9, 10. Yes, it's also between what 8 to what, let me say, to 10, the strong what base. So if you want to draw what the pH curve for this, now let me draw the graph. Let me draw the graph. So the curve here, we are plotting pH against this is what we are plotting pH against what temperature. degree C. So know that what this is what the origin. This place is what is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Good. So we all know that what we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yes. So this side, hello, it will be what? Volume of titrant. Titrant, sorry. And again, here, acidity increase, basicity increase. Sorry. So the pH for strong base is between what? 12 to what? To 14. Sorry. Because basicity is increased. So yeah, what will be the curve of this now? It's a strong acid. Your graph will start, it will be between 1, 2, 3. If it's 3 upward, it don't become what? Weak acid. If starting, but so because it's strong acid, I can start my graph either from 1, from 2, from 3. But let me pick it from what? From 2. So now go like this. It will go up like this. So it will now hit what? End point like this. If you look at the what? The curve now, the graph, you can see it that the graph here started at 2. These 2, the pH is what? A strong acid. And the end point of the graph here is what? 14. But if the graph end at 12, it's still what? Strong acid. End at 13, it what? Has got acid. So this curve is a graph of what? Of strong acid and a strong base. This is titration curve for strong acid and what? And strong base. Let me reduce the what? The length. I can use this place for another curve. Yes. So, yeah, let me use this way for the. You can also have titration. This is strong acid versus what? Yeah, there was what? Weak acid versus what? Strong acid versus what? Weak base. Yeah, strong what? Acid versus what? Weak base. In this one now, we know that what? The strong acid pH is what? Is still between 1 to 3, but weak base pH is what? From 7. Let me say from 8 to what? To 11. Is 8 to what? 11, weak base. So by plotting the what? The graph for the curve, we have something like this. I'll draw it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So is the graph of what? Strong acid and strong what? And a weak base. So your curve start from 1 or 2 or 3. Let the curve start from what? From 1. Go up like this. It will end at C. Look at this curve. So if you trace it now, it will end at what? At 11. It will end at 10 or 9. End at 10 or 9 or 8. You see what? Weak base. So this kind of curve represents what? strong acid versus what? Weak base. And the next one is the next one is strong, no, weak versus what? Strong base. For weak acid versus strong base, what is what? Cup. You have your cup in this form. Don't forget, here we have volume of what? Of tetrad. So this place is what? pH. You have P what? pH there. So here we have what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is what? Volume of tetrads. This. So from this side now, weak acid versus what? Strong base. So the pH of weak acid is between 4 to what? To 6.5. So the pH for what? That this one supposed to be what? Between 0 to, this one supposed to be 0 to what? To 2. So the weak is supposed to be what? 3 to what? To 6 upward. But 7 is neutral. So and the strong base is between what? 12 to what? To 14, the pH. So if you want to start the what? The curve now, you can say that what? Start it from what? From 4 or 5. So if I start my curve here, go up like this. Yes, go up like this. So now go up. What is strong base? Can you see it? So this is what? Graph of weak acid versus what? A strong base. So the next one is graph pH. We have graph of pivot H of, yeah, from 0 pH here. Sorry, I supposed to write the what? The title of the graph first. So the last one will be what? Weak what? Acid versus what? Weak base. So weak acid is 3 to 6. The curve. Weak base is what? Is 8 to what? To 10. Or to 11. 8 to 11. So by doing it now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What will be the graph now? 3 to what? 6 and 8 to 14. Where is 3? To 6. So the graph started from here. Can start from 4. Start from 4. Go up. 11 abi. Get to what? 11. You are now asked, this is what? pH. So this side is what? Volume of what? Volume of titrant. So that is all about what? The basic aspect of acid-base what? Titration. This is the curve. So in a multiple choice question, they will just give you the what? The curve like this, that, and they will calibrate the vertical axis. You will now ask which of the curve represents the titration of strong acid versus strong what? Strong base. What will be the option? You look at it. You know that it's start from the what? 1, 2, and this. You know the pH of strong acid and a strong base. It is what? Weak acid and weak base. Weak acid start from the what? 3, 4, 5, 6. And the strong base is 12, 12, 13, 14. So if it's for the what? Strong acid and weak base from the beginning and here, weak, this is what? This is the curve. So that is all about titration. Like I said earlier, if you want me to treat the calculation aspect of what? Of acid-base titration, you can put the comment on the what? You can drop your comment on the comment section. So if you need the video on the acid-base titration, how to calculate normality, molarity, and molality. And if you still need video on oxidation and reduction titration, can let me know, or video on complementary titration and the precipitation what? Titration. So don't forget to subscribe, like, comment, and share our YouTube channel. Thanks for watching.